I am presenting the architecture of an agentic AI system as a carefully designed hierarchy where each component has a specific role and clear interfaces with other components. This architecture is being built with modularity in mind, ensuring that each piece can be developed, tested, and maintained independently while still working together seamlessly. I am starting at the top with the user interface layer, which is serving as the entry point for all human interaction. This layer can take many forms. It might be a command line interface, TLI for developers, a web interface for general users, or an API for integration with other systems. The key point I am making is that this layer is responsible for translating human requests into a format the agent can process and then presenting the agent's responses in a human friendly way. The interface is handling user authentication, input validation, and response formatting. I am explaining that the agent brain is the central orchestrator of the entire system. This is where the React loop is implemented. The brain is receiving requests from the interface, managing the reasoning process, coordinating tool usage, and ensuring that responses are generated appropriately. The brain is not storing information itself, but it is managing the flow of information between all other components. It is like the conductor of an orchestra, ensuring that each section plays their part at the right time. I am describing how the memory system is tightly integrated with the agent brain. Every time the brain processes a request, it is consulting memory to understand the context and history of the conversation. After processing, it is updating memory with new information. This memory system is managing both short term conversation history and longer term context that persist across sessions. The brain is constantly making decisions about what information to store, what to retrieve, and how to use context to improve responses. I am showing you the horizontal interactions between three critical components that work together during the reasoning process. Enter to the registry, I am explaining that this is where all available tools are registered, managed. When the agent brain needs to perform an action, it consults the tool registry to see what capabilities are available. The registry is maintaining metadata about each tool, including their schemas, descriptions, and current availability status. Large language model, LLM. I am describing how the LLM is the reasoning engine that actually generates the thoughts, decides which tools to call, and produces final responses. The agent brain is managing the conversation with the LLM, providing context and tool definitions, and processing the LLM's responses. External APIs. I am highlighting that this represents all the external systems that tools can interact with. This might include search engines, databases, email services, calendar systems, or any other API that extends the agent's capabilities into the real world. I am explaining that information flows both vertically and horizontally in this architecture. User requests flow down from the interface through the brain to the memory and tools. Responses flow back up. Horizontally, the brain orchestrates communication between tools, the LLM, and external APIs during the reasoning process. I am emphasizing that this architecture is designed for growth. New tools can be added to the registry without changing the core brain logic. The interface can be replaced or multiplied without affecting the reasoning engine. The memory system can be enhanced or scaled without impacting tool functionality. This modular design is what makes agentic AI systems practical and maintainable in real world deployments.